Hello students, myself Manuj from Scholar Forum. Again, I have come up with one of the videos of this homemade video series. So our topic is liquid solution. In the previous topic, we discussed about the problems based upon Raoult's law. We saw how adding of a solute in a solvent changes its vapor pressure. Okay, now before moving to any further, I would like to ask you one simple question, and the question is, for a solution, which of the following is true? Delta G greater than 0, option A. Delta S greater than 0 means both positive. B, delta G negative, delta S also negative. Delta G negative, delta S positive. Delta G equals to delta S and both are positive. These four options are present. Pause the screen and try to do it on your own. Let's discuss this. Now, let's take an example, very easy example. Delta G and delta S. Firstly, let me tell you what is delta G and what is delta S. Delta G is Gibbs free change in Gibbs free energy. For any spontaneous process, spontaneous process means जो अपने आप से होती है. So for any spontaneous process, do you know delta G should be negative or delta G should be positive? Delta G should be negative for spontaneous. Do you know this thing or not? Good. Now tell me one thing. Suppose you have water. Let's see, you have water. Take a homemade example. And you have sugar. So when you dissolve sugar in water, you can perform this experiment in your home also. You take 1 glass of water, add 1 spoon of sugar and do nothing, just leave it like that. Okay, कुछ ना करिए, चीनी को पानी में मिलाइए और छोड़ दीजिए और ऐसे पड़े रहने दीजिए. ठीक है, आप देखेंगे, you will observe that not immediately but after some time, maybe few hours or maybe few days, entire sugar will be completely dissolved in water. Means you did not give it any outer source, supply from outer source. Means you did not provide any supply from outer source and sugar dissolved by itself. मतलब अपने आप dissolve हो गई sugar. तो ये spontaneous process हुई या non spontaneous process हुई? Is it spontaneous or non spontaneous? It will be spontaneous. So for spontaneous process, delta G should be less than 0. Clear? So delta G will be less than 0. So can this answer be correct? No. Delta G is greater than 0 here it is given, so it is wrong. Can this answer be correct? Yes. Delta G less than 0, it may be correct. Can this answer be correct? Delta G less than 0, yes, this may be correct. Is this answer correct? Delta G greater than 0, no. It is not correct at all. Okay. Now let's talk about randomness change. Delta S is change in randomness or entropy change. So tell me one thing. If you put your hand here in pure water, how many type of molecule you will find? You will find only one type of molecule. And that molecule will be what? That molecule will be water only. भाई पानी के ग्लास में अगर हाथ डालोगे तो जो चीज बाहर आएगी वो पानी तो होगी. ठीक. अच्छा. If you put hand in the sugar box, so which type of molecule will come out? Only sugar. You're getting this thing. But once you have a solution, means here what is present? Water plus sugar. Now put your hand inside. So the type of molecule which will come out, will it be only water? Or will it be only sugar? Or it will be both? It will be both. So tell me, here system is more random or here system is more random? Means solute are more random in nature or solution? It will be solution because solution में एक से ज़्यादा type के molecules होंगे तो वहाँ randomness ज़्यादा होगी. So for solution, tell me, from here to here, randomness increased or randomness decreased? Randomness 100% increased. So that means delta S will be greater than 0. So can this be answer? No. Can this be answer? No. This can't be the answer. So is this the answer? Yes. This is our answer. मतलब अगर आप दो चीजों को मिलाते हो, so randomness is always increased, so entropy will increase. And since dissolution is spontaneous, मतलब ये अपने आप डिसॉल्व होती है, नमक को पानी में मिला दो, add salt in water, it will itself dissolve. You will have to provide zero external energy. Maybe it will not be dissolved immediately, but after some time it will surely be dissolved. So dissolution is spontaneous process, so delta G will always be less than 0. Okay, let's move to the next concept. Now the next thing is colligative properties. Colligative properties means the property which depends upon only and only number or moles of solute particles is called colligative property. Okay, मतलब वो प्रॉपर्टी जो सिर्फ और सिर्फ डिपेंड करती है नंबर या मोल्स ऑफ सोल्यूट पार्टिकल के, उस प्रॉपर्टी को हम क्या नाम देते हैं? कॉलिगेटिव प्रॉपर्टी. ओके, देयर आर टोटल 4 कॉलिगेटिव प्रॉपर्टीज व्हिच आर रिलेटिव लोअरिंग ऑफ वेपर प्रेशर. Relative lowering of vapor pressure, in short we call it RLVP, relative lowering of vapor pressure. Second one is elevation in boiling point. We write it in short delta TB. This is a symbol by which we denote it. Third one is depression in freezing point, means delta TF. Delta TF, F stands for freezing, here B stands for boiling. And fourth one is osmotic pressure. We denote osmotic pressure by pi. Okay, again I'm repeating, the property which depends upon number or moles of solute particle present is called colligative property. 4 colligative property: RLVP, delta TB, delta TF and pi. There are 4 colligative properties. Okay, one thing you must be sure about this, these properties do depend only and only of numbers. Are you getting this thing? Only and only on numbers. These properties do not depend upon size, shape, mass, volume of solute particles. You're getting this thing? Means it is just like कि मुझे तुम कैसे दिखते हो, you are handsome, you are beautiful, you are ugly, you are thick, you are thin, you are muscular, you are lean. It doesn't matter which type of person you are. What matters to me is just you are present. The property which depends or which are affected by your presence only, irrespective of what your shape is, what your size is, what your mass is. So we call that property colligative property. Doesn't depend upon size, shape, mass of solute particles. So we must be clear about this first. Okay, so one by one we will discuss all these properties. Okay, so before moving forward we will move to the next concept. Okay, that concept is Vant factor. Now what is Vant factor? Vant factor is, it accounts for effective number of moles or particles present in solution. What it accounts for? It accounts for effective number of moles or number of solute particle present in solution. Why it is important to us? See, we are going to study colligative property, and colligative property depends upon number of particles. So we must know कि how many number of particles or number of moles are actually present in our solution, isn't it? पहले हमें numbers के बारे में पता तो हो कि कितने solute particle present हैं, पहले उनकी अच्छे से हम लोग स्टडी कर ले, then only we should move for colligative property, because colligative property depends upon number of solute particles. Okay, so let's see why I am saying why it is needed. Let's say you have NaCl. Okay, NaCl, what you did, you added NaCl in water. Water is what? Solvent. NaCl is solute. So you know, when you dissolve NaCl in water, it gets dissociated, it gets ionized, and it gives you Na plus and Cl minus. Are you getting this thing? Okay, that means, tell me, how many particles you can see NaCl here? How many particles you have here? You have just 1 particles. Now here how many particles you have? You have 1 particle. But when you added particles in water, when you added NaCl in water, it gave you 1 particle. No, it gave you 2 particles. See, this is your 1 particle and this is your 1 particle, isn't it? So total particles how many? Total particles, 2 particles. Okay, तो हुआ क्या? What happened here? You added 1 particles and you got how many particles in water? 2 particles. But tell me, when you will be performing experiment, you will be knowing about the particle of NaCl, na? You NaCl particle, you know, you thought, okay, I am adding 1 particle here, but ultimately what is happening? You are getting how many particles in the solution? 2. भाई तुमने तो सोचा कि एक पार्टिकल तुमने NaCl का डाल दिया, लेकिन अंदर जाकर के क्या हुआ? वो एक किस में कन्वर्ट हो गया? 2 में. तो अब बताओ, तुम्हारे पास जब 2 पार्टिकल आ गए, और कॉलिगेटिव प्रॉपर्टी किस पे डिपेंड करती है? कॉलिगेटिव प्रॉपर्टी डिपेंड्स अपॉन ओनली एंड ओनली नंबर ऑफ पार्टिकल, डजंट डिपेंड अपॉन योर नेचर. कोई फर्क नहीं पड़ता whether you have positive charge, you have negative charge, doesn't matter. Why? Because colligative property is number dependent only. So for colligative property, let me tell you, whatever property Na plus will show, the same property will be shown by Cl minus, the same property will be shown by Ca2 plus, the same property will be shown by Mg2 plus, the very same property will be shown by glucose molecule, the very same property will be shown by sucrose molecule, very same property will be shown by H plus, very same property will be shown by OH minus, very same property will be shown by all particles present in this universe. Are you getting this thing? Provided they are acting as solute. Okay? जैसा मेरे लिए Na प्लस है, वैसा ही Cl माइनस है, वैसा ही NaCl है. NaCl मीन्स अगर ये मतलब एक दूसरे से अगर अलग ना हो, NaCl मीन्स NaCl टुगेदर, नॉट Na प्लस एंड Cl माइनस. सो जैसा Na प्लस है मेरे लिए, exactly the same is my Cl minus, exactly the same is my CH3COOH undissociated. Okay, exactly the same as Ba2 plus, exactly the same as glucose, fructose, urea, whatever solute you have. If number of particles are same, so everything is same for me. So here, whatever effect is produced by Na plus, I'm talking about colligative property. So the same effect will be produced by Cl minus. So you thought earlier I am dropping 1 particle, but it got converted into 2 particles. So actually, effectively, how many particles you have? You have 2 particles. Are you getting this thing? So how do we define I? I is equals to number of particles or moles, whatever you have, because 1 mole equals to Na particle. So number of particles after dissociation or association upon initial number or moles of particle. Reading the same. This is your I. Okay. For example, in this case, NaCl gives me Na plus and Cl minus. So tell me, how many final particle I have? How many particle I have? I have 1 plus 1, that is 2. How many initial particle I had? I had just 1 particle. So 2 by 1. So I for NaCl will be equals to 2. Are you getting the same? So if somebody tell me I have 2 moles of NaCl, I am dropping these 2 moles of NaCl in water. So you tell me, will I calculate colligative property corresponding to 2 moles? No. You know, I will calculate the if colligative property corresponding to not 2 but 4 moles. Are you getting the same? How will I get this? Number of particles after dissociation or association, it is nothing but, it is whatever written in numerator, it is nothing but, it is effective particle. So effective particles equals to initial particle multiplied by I. Note this and note this. Okay. Now returning to my question, if I add 2 moles of NaCl, so effectively how many moles I am adding? I am adding 2 into 2 moles. Are you getting this thing? Means multiplied by I. So effectively how many moles I am adding? I am adding 4 moles of what? Particles. 4 moles of particles. Clear है बात ये? Okay, let's do one more. Okay, now find I of the following in water. You have to find Vant of factor of the following gases: K2SO4, AlCl3, K2SO4 dot Al2SO4 whole thrice dot 24H2O. It is called potash alum, glucose, urea. Okay, I will solve for you K2SO4 I will solve. Please pardon the background noise. As you know, this video is being shooted in my home and so much background noise you can feel. So please try to ignore that. Okay. Now K2SO4. You know, if we add K2SO4 in water, so this K2SO4 will convert into 2K plus and SO4 2 minus. Okay. Good. Now, let's take one particle, let's take A moles of K2SO4 in the beginning. So, how many moles of K plus I will have? I will have 0 here, 0 here. Okay. K2SO4 is a strong electrolyte or weak electrolyte? K2SO4 is a strong electrolyte because it is a salt. All salts are strong electrolyte except precipitate. So, after it will become 0, it will be completely dissociated. How many moles of 2K plus you will see? You will see here 2A. How many moles of sulfate you will see? You will see A. Are you getting this thing? How many particles you added? You added A particles in the beginning. And how many particles you are getting in final? You are getting 2A particle. No. Are you getting A particle? No. You are getting final particle equals to how much? Final moles equals to 3A. 3A how? 2A plus A, that is 3A. And initial moles will be how much? It will be A. So, I will be equals to how much? Tell me how will I will be equals to how much? I equals to final particle upon initial particle. How much it will come? It will come 3 upon A, that is 3. Are you getting the same? Clear? I calculation is clear? Good. For a strong electrolyte, you can think in this manner, if whatever number of particles we are getting from 1 mole, that is I. Repeat करूं? किसी भी strong electrolyte के लिए एक पार्टिकल से जितने भी पार्टिकल्स मिल रहे हैं, जैसे यहाँ एक K2SO4 हमें कितने पार्टिकल दे रहा है? हमें 2K plus दे रहा है और एक सल्फेट दे रहा है. टोटल पार्टिकल 3 दे रहा है. That is your I. Okay? So I equals to how much here? 3. So suppose if I take 2 moles of K2SO4, 2 moles of K2SO4, तो मेरे पास इफेक्टिव मोल्स कितने हैं? इफेक्टिव मोल्स, टेल मी हाउ मेनी इफेक्टिव मोल्स आई हैव? इफेक्टिव मोल्स इक्वल्स टू I into 2. I is how much? 3 into 2, that is 6 moles. But I am talking about which property? Colligative. For colligative property, I have effective moles 6. If you calculate by putting 2 moles in your formulas, you will get wrong answer because 2 K2SO4 will give you 6 particles, isn't it? So that's why answer will be different. So please be focused on this I. I पे command बनाइए. Somehow कैसे भी करके I पे हमें command करना है. For that purpose, you have to do LCl3 on your own. This K potash alum on your own. Let me tell you, we will not count this water. Water particles count करने की जरूरत नहीं है. Why? Because when you add water and water, nothing makes sense. We just have to count this. Okay. Let me tell you about glucose. Glucose is electrolyte. Means if we add glucose in water, so will it get dissociated? No. So means if you add glucose, not just glucose, if you add urea also, urea, or if you add sucrose, so suppose if you add them in water, they neither dissociate nor associate. मतलब वो ना तो टूटेंगे ना जुड़ेंगे. Means if you added 1 mole of glucose in water or 1 mole of sucrose in water or 1 mole of urea in water, ultimately you will get just 1 mole in the end. मतलब ये ना तो टूटते हैं और ना ही ये जुड़ते हैं. मतलब ना तो नंबर्स बढ़ेंगे इनके पानी में जाने पर और ना ही नंबर्स कम होंगे. So I for these solute will be 1. always. Remember this. Okay, that's why I'm solving it here only. Okay, try these B and C part on your own and write your answer in the comment section. Okay, moving forward. Now, the next question is CS3COOH has degree of dissociation 0.1 in water. Degree of dissociation of CS3COOH is 0.1 in water. What you have to do? You have to find its Vant factor. Okay, इस क्वेश्चन में से करेंगे. Let's see. If you want to give it a try, pause the screen and try on your own. Okay, let's see. CS3COOH. Tell me, CS3COOH is a strong electrolyte or weak electrolyte? CS3COOH is weak electrolyte. It is weak acid, na? So let's see. If I have A moles in the beginning, how many moles of CS3COO minus will be there? 0, 0. It will be at T equals to 0. Clear? Now, after some time, if degree of dissociation is alpha, so I can write it as A minus A alpha. Can I write this? What is alpha here? Alpha is degree of dissociation. You know how do we do this? Good. Now, if you are getting subtracting A alpha here, so CS3COO minus will be formed. A alpha. How much H plus will be formed? A alpha. Is this clear? Now, can you tell me how many final particles you have? Final particles. How many final particles do you have? You have, see, A alpha plus A alpha. That's it. No, you have some CS3COOH also which is undissociated. Are you getting this thing? You have some CS3COO minus, you have some H plus, but also you have CS3COOH. And for me, CS3COO minus, H plus and CS3COOH all are same as long as I am talking about colligative property. Okay? जब तक कॉलिगेटिव प्रॉपर्टी की बात चल रही है तो चाहे CS3COO माइनस हो, चाहे वो H प्लस हो, चाहे वो CS3COOH हो, सब एक समान है. तो A अल्फा CS3COO माइनस का बचा, A अल्फा H प्लस का बचा और CS3COOH का कितना बचा? A माइनस A अल्फा. तो प्लस A माइनस A अल्फा. अच्छा, इनिशियल पार्टिकल कितने थे? इनिशियल पार्टिकल कितने थे? A. बिगिनिंग में तो यही थे. आई कितना होगा जरा देखना. आई विल बी इक्वल्स टू सी कितना हुआ? ए अल्फा से अल्फा कैंसिल हो गया. दिस केम ए प्लस ए अल्फा ना. सो आई विल बी ए प्लस ए अल्फा अपॉन ए means it came as 1 plus alpha means 1 plus 0.1 means 1.1. Getting this thing? Good. Now see, I hope you understood here. There was no role of A. A got cancelled out because we are taking a ratio. So A is supposed to be cancelled out. So that's why I'm in all the question I'm taking A everywhere. There is no need to take A. If you want, you can take 1 also. Is this clear? Let's move to the next question. Now, the next question is, if degree of dissociation in the following equation which is given to you is alpha, so find I. Okay, pause the screen and try it on your own. Okay, let's see. Firstly, can you tell me what is the meaning of AN? AN means you have n atoms of A together. So it will be called associated form or dissociated form. It will be called associated form क्योंकि यहाँ पे क्या है, सब लोग एक साथ हैं, all are together. What is this? Here I have written n atoms of A, means A plus A plus A plus A, how many times? N times. So it is dissociated form or associated form? This is dissociated form. So AN is getting dissociated or associated? So AN is getting dissociated. Okay, now let's see. Let's say in the beginning I have A moles. Although you know there is no use to write this A, so it will be 0. After some time it will become A minus A alpha. Okay, because degree of dissociation is alpha. So can you tell me how much it will be formed? It will be Na alpha, isn't it? 1 gives us N, एक AN से बनते हैं Na, तो A alpha से कितने बनेंगे? Na alpha. 1 AN gives me Na, so A alpha will give me Na alpha. Okay, now tell me final particle. Final particle is how much? I have Na alpha. No, Na alpha plus A minus A alpha. Means how much I am having? I am having A plus, I think, N minus 1 into A alpha. Can you see this thing? alpha common, so n minus 1. Now initial particle is how much? A. So what will be I? I will be A plus n minus 1 A alpha divided by A. Final particle divided by initial particle. So here I is coming as 1 plus n minus 1 alpha. And it is the general formula for calculation of I. Okay? Vant factor के calculation के लिए it is general formula. What is n here? Let me write what is n. N is number of particles obtained by dissociation or association of 1 mole of 1 particle of solute. Are you getting this thing? What is n? Number of particles obtained by dissociation or association of 1 particle of solute. कि एक particle of solute जितना भी आपको total particles देगा, that will be called n. Okay? So in this case, what is the value of n? n. एक an से कितने a बन रहा है? n. Okay. I gave you the example of NaCl. For NaCl, can you tell me the value of n? N की value होगी यहाँ पे 2. Why? Because each NaCl will give me 2 particles. Now, one molecule will give me 2 particles. Can you tell me what will be the value of n for K2SO4? K2SO4 will have n equals to how much? K2SO4 will give me 3 particles. 3. Clear? Good. Now one more thing is happening here. Alpha is what? Degree of dissociation. So for strong electrolyte, degree of dissociation is what? 1. Always. Strong electrolyte have 100% dissociation. So let's calculate I for K2SO4 by this formula. I for K2SO4 by this formula. So how will I calculate? I equals to 1 plus n minus 1 alpha. 1 plus for K2SO4, what is n? 3. So 3 minus 1 into 1. Isn't it? Alpha equals to 1. So it will come as 1 plus 2 means 3. That we have already done. So this is a general formula for calculation of I. Okay. Moving to the next problem. There are 2 questions I have written in this board. First is you have to find I for 2A gives A2. 2A gives A2. And you have to find I for this reaction also. 3A reversible A3. 3A reversible A3. Okay. Pause the screen and try it on your own. Okay. So I am solving one for you. Let's see this one. Here, can you tell me what is the value of n? What will be the value of n here? N means particles produced by 1 particle of solute. See here what is happening. 3A are producing 1A3. 3A मिलकर के एक A3 बना रहे हैं. Okay? तो ये एसोसिएशन हो रहा है या डिसोसिएशन हो रहा है? Is it association or dissociation? It is association. अब ये लोग टूट नहीं रहे हैं. They are getting combined. ये लोग जुड़ रहे हैं. तो 3A से मिल रहा है 1A3. Okay? So it is association, not the dissociation. So if 3 particles are giving me 1 particle. Okay? So for calculation of n only, 1 particle will give me how many particles of A3? 1 by 3. So 1A will give me 1 by 3A3. So n की value यहाँ पे कितनी है? What is n? N is 1 by 3. Is it clear? 3 particles give me 1 particle. So 1 particle will give me 1 by 3. Unitary method. So n is equals to 1 by 3. So what is I? I is equals to 1 plus n minus 1 alpha. So it will be 1 plus 1 by 3 minus 1 into 0.2. So it is coming as 1 plus, see, it will become minus 2 by 3 into 0.2, means it will become 1 minus 0.4 by 3. Okay, so it will become 1 minus 0.133, etc. and so on. 0.133 na? Okay, so it will come as 0.863. So this will be your, 867. So this will be your answer. We're getting this in 0.867. Is it clear? Any doubt? Very good. Let's move to this question. Try it on your own. Okay, let me tell you here, I will come as half. I will come as half. You have to do it on your own. Okay, good. Moving forward. Now, I hope you have realized, okay, if I is greater than 1, I greater than 1 means effective number of particles are increasing. So if I is greater than 1, so we say what is going on? Dissociation. Are you getting this? If I is less than 1, is it possible that I can be less than 1? Yes. In that case, it will be association. Remember, for NaCl I was 2. For the previous question, A2 gives A2 gives A2, you got I equals to half. 3A reversible A3, I got I equals to 0.867. In the same manner, I less than 1 जब भी होगा, so it will be association. I greater than 1 जब भी होगा तो dissociation, और vice versa. और I equals to 1, so neither dissociation or association. Okay, good. Let's move to the next problem. Next question is, in a particular solvent, CS3COOH is 50% dissociated and 50% associated. I should correct it, associated, you could write it here, dimerized. Okay, so 50% dissociated and 50% dimerized. Find I for CS3COOH. Okay, if you want to give it a try, pause the screen and try on your own. Let's see. हमसे क्या बोला जा रहा है कि we are having CS3COOH 50% dissociated and 50% associated. So for such question, I will suggest you better take some amount of some moles or some numbers of CS3COOH. Okay, doesn't matter what number you want to choose. If you want to choose 1 CS3COOH in the beginning, choose 1. If you want to choose 10, choose 10. If you want to choose 100 CS3COOH, choose 100. So for safe and easy purpose, I am selecting, let's take 100 CH3COOH in the beginning. Okay. Now here, out of 100, I will divide it into 2 parts. Means 50 CS3COOH and 50 COOH. Okay. 50 CS3COOH here and 50 CH3COOH here. Why? Because 50% here and 50% here. One of the side will go for dissociation. One of the side will go for dissociation. You know how CH3COOH is dissociated? CH3COOH is dissociated like this. CH3COO minus plus H plus. Do you know this? Good. Now, they are saying 50% is associated. 50% associated means it 2 CH3COOH. They are saying it is getting dimerized. Dimerized meaning that 2 particles are becoming 1. Do you understand the meaning of polymerization? Polymerization means when so many number of particles club together and they make 1 particle. So dimerization means 2 particles will club together to make 1 particle. Similarly, trimerization means 3 particles will club together to make 1 particle. So what is happening here? 2 CH3COOH will give us, see, CH3COOH whole twice. This is the meaning of dimerization. Okay, meaning is clear. Let's see. So here I got 50 particle, 0, 0. Here I got 50 particle, 0. Clear? Now, after some time, how much it will be? 0. Because they are saying if 50% is dissociated. So it will become 0. How many CH3COOH minus I will get? 50. How many H plus I will get? 50. Is this clear? Now here, how many particles will be left in the final? 0. Because they are saying 50% is dimerized. So 2 gives me 1. 2 CH3COOH gives us 1 CH3COOH whole twice. So 50 will give me how much? 25. Clear? Good. So now tell me, final particles. How many final particles you have? Final particles, how many? Final particles are, see, 50, 50. No, see, CH3COOH is over. It is no longer left. 50 plus 50. Just 100? No. 25 as well. Because 25 are now associated, na? So plus 25, and for me, CH3COOH minus, H plus, CH3COOH whole twice, everything is same, because I am talking about colligative property, and colligative property does not think whether you are handsome, you are stupid, you are duffer, you are fool, you are stupid donkey. It doesn't matter. You are just present there. Colligative property is like that. So 50 plus 50 plus 25, that means 125. So it is your final particles. And the initial particle, how many initial particles I had? Initial particle, how many I took? I took 100 particle. So 100. So I will be how much? 125 divided by 100 means 1.25. You're getting the same. Good. Let's move to the next problem. In a solvent, next problem is, in a solvent, 40% of CH3COOH is associated and 40% is dissociated. Find I for CH3COOH. Okay. 40% dissociated hai, 40% associated hai. So what about rest 20%? 20% is as it is. 20% is as it is. So would you like to give it a try? Yes. This question you have to solve only. I will not solve, and answer for this question will come as let me solve 1.2. You have to solve this on your own. Okay. Now you may get to see one more formula written in your notebook or in your textbook. That formula is I equals to abnormal or experimental colligative property upon normal or theoretical colligative property. मतलब जो abnormal colligative property आएगी means which will be experimental divided by abnormal colligative property or normal colligative property or theoretical colligative property. Theoretical means जो calculate की जाएगी formula से. Okay, and the very same is equals to normal molar mass divided by abnormal molar mass. How these two formulas are coming, we will see in the upcoming videos. Okay, so up to here your task will be just go through all the questions which I gave in this video only and try to solve them on your own without seeing the answer. If you are able to resolve them, that will be very easy for you, and further it will give you very less pain to solve such type of questions. Okay, see you in the next video.